Today we are going to talk about solving inequalities. And before we do that, we need to look at the rules. Do the same rules apply to solving inequalities as those to solving equations? So let's look at this example. 5 is greater than 3. We all know that. What if we add the same number to both sides of this inequality? What will happen? Will inequality hold? We have 7 is greater than 5, which means it does hold. It's true. How about if we subtract a number, the same number from both sides, or add a negative, which is the same thing? We add -2 to both sides. What do we have? 3 is greater than 1. So inequality does hold. It's true. So obviously we can add or subtract the same number from both sides of inequality, and the inequality will be true. It will hold. How about multiplication? We multiply both sides by 2. We have 10 is greater than 6. So it does hold. How about multiplying by a negative number? We end up with a -10 is greater than -6. Oh, but that does not hold. -10 is actually less than -6. This is the only difference between solving inequalities and equations. When you multiply, and this applies to division as well, both sides of inequality by a negative number, the inequality sign does not hold. It has to be flipped. So remember that, and let's go with this. So the first two examples involve addition and subtraction. And the first one, we have variable added +8. We undo it by subtracting a +8, and we end up with -10 is greater than or equal to m. It might be actually much easier to read from the variable, because then it will be more clear how to graph the solution set. M is any number is less than or equal to -10. Now to graph it, we put the number line and we put -10 in the middle and a few numbers greater than -10, few numbers smaller. We need to close the dot because of the half of equal sign, because a -10 is a possible solution to this inequality, and then any number less than -10 is a solution, which is to the left. For the second example, we have subtraction of 5 being done to both sides. We add 5 to undo it. We end up with v is less than 17. To graph the solution set, we put 17 in the middle, few numbers larger, few numbers smaller. And then, because we do not have that equal part underneath the inequality sign, 17 is not a possible solution. Only numbers smaller than 17 are. Because of that, we'll put open circle on 17, and all numbers smaller than 17 are solution. Now let's look at multiplication and division. The first example, we have g divided by 2 is greater than 7. We need to undo division by multiplying both sides by 2, which ends up having g is greater than 14. To graph it, we put the number line, few numbers greater than 14 and smaller. Because we don't have equal sign underneath inequality sign, 14 is not possible solution. We put open dot, and all numbers greater than 14 a solution. For the example, we should evaluate 5 squared first. And then we undo multiplication by dividing by 5. The same to the other side. We have n is less than or equal to 5. Because of the equal sign, 5 is a possible solution, so we should put close dot on 5, and all numbers less than 5 are a solution. Now let's look at how this applies to real-life situations. It costs a bakery company $72 to make cakes. How many cakes must it sell at $12 a piece to make a profit? Write an inequality with a variable for the unknown to represent the situation and solve. Here is the same problem for your viewing. The first thing we need to decide here is what's the variable, because we don't know how many cakes must we sell. We put C for number of cakes sold as a variable. And another thing that we need to take in consideration is the fact that to earn profit, as we know, income has to be greater than expenses. So knowing that, 12 times number of cakes sold has to be greater than 72, which is the expenses for the bakery. To solve this, we divide both sides by 12, and we have C to be greater than 6, or C is greater than or equal to 7, which means that the bakery must sell more than 6 cakes, or at least 7 cakes to make a profit. Now let's look at the two-step equation, inequalities, we need, as the same as with equation, we need to undo addition first. We subtract 3 from both sides. We have 2x is greater than negative 15. We undo multiplication by dividing by 2, and we have x is greater than negative 7.5. Now let's do this one. Before we do it though, let's remember, when multiplying or dividing both sides of an inequality by a negative number, we need to switch the inequality sign. So to solve this inequality, we need to undo addition by subtracting, and we have negative 3x is less than 18. We undo multiplication by dividing by negative 3 both sides. And because of this step of dividing by negative 3 both sides, we need to flip that sign there. We have x is greater than negative 6. Let's see the application of two-step inequalities. A phone company charges $29 per month and 2 cents per minute of long distance. If you want to spend no more than $40 per month on the phone calls, how many minutes can you use? We need to write an inequality with a variable for the unknown to represent the situation and solve. Here is the same problem for our viewing. The first thing we need to decide is what's the variable. Because we do not know number of minutes, that's our variable. So M is number of minutes. And we also need to think that what we spend cannot be more than 40, which means can be equal to 40 and can be less than 40. And now we can write the inequality. We have $29, which is regular charge, plus 2 cents times number of minutes spent on phone calls is less than or equal to 40. Undo addition of positive by subtracting a positive. We have 2 cents times number of minutes is less than or equal to 11. Divide both sides by 0.02. We end up with M is less than or equal to 550, which means number of minutes we spend on a phone call can be maximum 550.